And what you're finding then, if you've gotten to this page, it says the following is a list of conjectures. Conjectures are just kind of hypotheses, educated guesses made by students about right triangles and their trigonometric relationships. So a couple things right there vocabulary wise. The trig relationships that we have right here, these trig relationships that we're setting up right now apply to only right triangles. And what those trig relationships are is what we did yesterday when I had you write down the little phrase SOHCAHTOA. So that's what this phrase is referencing. Then it says, for each of these statements, basically what we're going to do is determine if these guesses that the students came up with that seem to be true in their minds are actually in fact true, or if they ended up being false. And then we'll justify our answers. So for number one, what it is saying, number one's a nice one to start with, just a basic cosine and sine problem. So it's saying if I went to angle A, so that's this angle here, and I looked for the cosine value. So since we want a cosine, that's this middle three letters. The cosine is always equivalent to the adjacent side over the hypotenuse. So we want the adjacent over hypotenuse for angle A. So if we revisit angle A has two adjacent sides. Here's one adjacent side. Here's the other adjacent side. So we mentioned that yesterday. One of those is the hypotenuse, however. So while we have those two adjacent sides, when we reference the word adjacent here, it references the side that's adjacent, but is not the right hypotenuse. So that in this case is a 4. So the cosine of angle A is 4. And then we're going to divide that, since its cosine is adjacent over hypotenuse. Oh, not a good start though, Mr. Kuwitz. Come on. There we go. And the hypotenuse was 5. And then now, this is just jumping around, not touching anything. Yeah, we'll see if after this one, if it continues. If I want the sine of angle A, the sine is this one. So the sine of any angle is the opposite side of that angle. So angle A's opposite side is 3 over the hypotenuse. The hypotenuse is the 5. So we can find the cosine of A. We can find the sine of angle A. When we look at those, we see that those obviously are not equal to each other. So when we are told to say if this is true or false, in this case, we would say that this is false, that the cosine of that angle is not the same as the sine of that angle. Okay. But that's all we're doing for these 6 problems, is just, one, reviewing these. It's a nice little review of all these properties, and then determining ultimately if it's a true statement or not. So in the next one, you want the tangent of angle A. So we're still dealing with angle A. And we want the tangent. The tangent is over here. The tangent is the opposite side over the adjacent side. So go to angle A. The opposite side of angle A we've already got. It is the 3. The adjacent side of angle A is the 4. So we would say 3 divided by 4. So that's our left-hand side. The right-hand side, though, we're going to do 2 different values, and then we're going to divide them. So the first one we're going to find is the sine of angle A. Don't think too hard about this, right? Didn't we just do that in the problem above? So if I want the sine of angle A, we just did that up here. So we found the sine of angle A to be 3 over 5. So now we're going to make that our numerator. So we have 3 over 5. And then we're supposed to divide that, so I now have my fraction bar, by the cosine of angle A. And if we revisit number 1, you also have done this one. So here is the cosine of angle A. We found that to be 4/5. So we're going to divide this by 4/5. And then now what we need to see, are those in fact equal to each other? So we want to know, is 3/4 equal to 3/5 divided by 4/5? If you have a calculator, you could certainly plug that into your calculator. That is certainly valid, perfectly legal. And if it gives you a 3/4, that's true. If it doesn't give you 3/4, then we're going to say that this is false. So we could use our calculator, but as the math teacher, I'm going to show you how to do this without your calculator. If you think back, I don't know when you do this in your lives, but when we divide by a fraction, so notice how I'm taking that 4/5 and I'm dividing by that. When we divide by a fraction, it is always equivalent to multiplying by the reciprocal of whatever your denominator is. So instead of dividing by 4/5, we could multiply by the reciprocal of 4/5. Those two things mean the exact same thing. This now should be easy. At some point in your lives, you've cross-canceled. Notice how the 5s are going to cancel each other out, leaving a 3 in the numerator, a 4 in our denominator. So this fraction does, in fact, reduce down to be 3/4, which is the same thing we get on the other side. Those are, in fact, equal to each other. So in this case, you're going to say true. All right, so we've had one false, and then we've had one true. All right, the next one is a tricky one. So let's do the sine of angle A first, which we've done already twice. So let me move this up. So the sine is opposite over hypotenuse. We've already found the sine of angle A right here. And that's the same thing that this question is asking. So we know the sine of angle A is 3/5. But then we come over here and we have this weird cosine of 90 degrees minus A. And it's kind of like, what does that really mean? So what that's referencing, so if we go over here, look at our triangle, what we know is the angles in a triangle. So angle A, C, and B. We know those all have to add up to be 180 degrees. Notice how we already have 90 degrees accounted for right here. So what I'm going to do is I'm going to subtract away those 90 degrees. What we are left with is a total of 90 degrees remaining. Well, don't we have two angles, A and B? Don't those have to then together add up to be 90 degrees? So if this was like a 20-degree angle, this would be a 70-degree angle. And then that's going to give us our 180. So the sum of angle A and angle B need to add up to be 90 degrees. All right, so let me write that if this thing will work. Here we go. So what we're going to set up is a little equation that we know has to be true. That angle A plus angle B, those must add up to be the remaining 90 degrees of that triangle. So we've already got a 90-degree angle accounted for. All right, so with that understanding, let's do a little bit of algebra here. So last year you would have done things like systems of equations. We did this a little bit with x's and y's earlier. Let's say I tell you to solve this equation for B. So if I now tell you to isolate B, get B all by itself, what that would require us to do is subtract. Let's get rid of the A. So if we want B by itself, we want to get rid of the A. So let's minus A from both sides. And what we see is B is equal to 90 degrees minus angle A. All right. So the reason we do that, so I can kind of show you what this means, create a little bit of space here. There we go. Is look at what we're dealing with. Notice how this says we want the cosine of angle 90 degrees minus A. So this little expression, didn't we just create that little expression over here? So 90 minus A, 90 minus A. What is 90 minus A equivalent to on the other side? Isn't that really just angle B? So when you see this expression here, all that's really asking you is to find the cosine of angle B. All right. So now do that. If we kind of understand that, go to angle B. The adjacent side to angle B would be the 3. And the hypotenuse to angle B would be angle 5. First one was false. Second one was true. When we look at this here, we see that these end up being the same. So this is, in fact, also a true statement. Okay. So notice what just happened, and this will always be true. If I did the sine of one of the angles, the non-90 degree angle, and then I do the cosine of the other one, those will always end up being equivalent. Okay, 100% of the time. So we now go to this one. That's exactly what this question is saying. If I want the cosine of one angle and the sine of the other angle, this should be true. Okay, so we'll kind of show it, but those should end up being equivalent to each other. Let me come back up here. So I want the cosine of angle A. So that's this angle. Cosine is the adjacent side over your hypotenuse. So that's 4/5. And then I want the sine of angle B. All right, this one we have not done yet. So if we go up here to angle B, we're doing this. The sine of angle B is the opposite side over the hypotenuse. So I should have 4/5 for the sine of angle B. We see that those are in fact equal. So this one is true. All right, number 5, one of these other weird ones now. All right, so cosine of B, already did it, right? Cosine of B, we found to be 3/5. So that's the easy one. And if you just need to do it on the triangle again, most of us at this point, hopefully with the SOHCAHTOA idea, we're understanding those ratios. But then we come across the same little expression. So I'm going to reference us back to this equation here, that the angle A and the angle B, they need to add up to be the remaining 90 degree angles in that triangle. So A plus B must add up to be 90 degrees. I'm going to have you once again solve for B. So in order to do that, maybe I shouldn't have done that just yet. We're going to subtract that A over so that they cancel here. Notice again how the B is equal to 90 minus A. So this 90 minus A over here, we are told that is the same exact thing as B. So what this is really asking us to do is find the sine of angle B. You can use your triangle. We've already done this a few times. We actually just did it in the previous problem. Here is the sine of angle B. We get 4/5. So we can now see that 3/5, in fact, is not equal to 4/5. So this one ended up being false. All right. All right. Last one of these, because we're just gonna do these 6 on this page. Do those 2 problems. So find the tangent of angle A, and then find the tangent of angle B, and then that's going to go into your denominator. So do those. These are both new, I think. I don't think we've done either one of these yet. Good. So we haven't done tangent. So find the tangent of A, find the tangent of B. So get those real quick. So the first one, we want the tangent of angle A. So find angle A. First time we've done tangent today. The tangent is the opposite side over the adjacent side. So tangent is opposite over adjacent. So if we're going to do angle A, here's angle A. The opposite side of angle A is 3. The adjacent side of angle A is a 4. So that would give us 3/4. And then you're going to do the same thing with angle B, but it's going to go in underneath the 1. It's going to go into a denominator. So if we go back to finding the tangent, it's still an opposite over the adjacent, but we're going to do that with angle B now. So here's angle B. This guy right here. Its opposite side is 4, and its adjacent side is a 3. So it's 4 over 3. All right, so 3/4 equals 1 over 4/3. We now need to determine if that is true. We talked about this earlier. When we are dividing by a fraction, so when I'm dividing by 4/3, instead of dividing by a fraction, which most people don't remember how to do or understand, it's the same as multiplying by the reciprocal of your denominator. So change this division into multiplication, and then take the reciprocal of 4/3. 1 times 3/4 is 3/4. So this does equal 3/4, which is the same thing we got on the other side. Those are in fact equivalent. So that is going to be a true statement. All right. So good little review of all the SOHCAHTOA stuff, those relationships, those fractions, those are things that we need to make sure that you know moving forward when we get into that next section. All right, next, we're not going to do 7, 8, and 9. Those are even more beyond what we really need to be doing. What I want you to do is go to the next, skip ahead 2 pages. So the next page, it says homework. This is not going to be your homework. But go down to number 17. And then notice what your directions say. Find each of the following values using your graphing calculator or a calculator. If you have a graphing calculator, I'm going to show how you're going to do this here in a minute. Next thing, you need to make sure that your calculator is in what we call right here degree mode. So what you need to do is go to your calculator. Up here is the word mode. Click on that key. So if I click on the word mode right here, you're going to see a bunch of options going up and down. Well, if you go down to this 4th line, at least it's the 4th line for me. It might look a little bit different depending on what version of this calculator you have. Notice how you see the word radian and the word degree. So actually, before you even click down, as long as the word degree is in black, you are good. You don't have to change anything. If your calculator is in the word radian right now, then you need to move over, hit enter, so that the degree word is the one that's highlighted in black. Right here, the word mode. So up here, right next to that blue key, click that one. So then you're looking at this screen. And then what you want to make sure of, so initially your guy would have been at the very top. So now look at your calculator. Is the word degree, is that darkened right now, Andre? All right, so what that would then mean, you are probably looking at this right now. So on your calculator, is the word radian highlighted? All right, so what you need to do is arrow on down so that the flashing is flashing over the radian word. And then we don't want to be on that. So now use your arrow to move over. See how I'm flashing on degree. Hit enter. And then now radian is no longer highlighted, but the word degree is. All right, so that's what we need to have. All right, everybody else, we got that? You will not be able to do these without a calculator. So you need to make sure you're in the right mode. You need to know how to handle this. All right, we all good? All right, so then the first thing we're going to evaluate in this one is the sine of 21. So this is number 17, the sine of 21 degrees. So you now need to find this key on your calculator, right? So we want the sine function. So if we look right in here, right in the smack dab in the middle of your triangle, you're going to see sine, cosine, tangent. Since we want sine of 21, you're just going to click on that key, throw in the numerical value of the degree measure that I want, close it, and when we hit enter, you should get 0.358. All right, before we go on to the next one, anybody not get that? Anybody not knowing what they're doing with their calculator right now? All right, I don't believe you, but if we're all good, go to the next one and do the tangent of 22. So in the same spot in your calculator, sine, cosine, tangent, since we now want the tangent of 22, so this is just number 18, I throw in 22 for the parentheses, close your parentheses, so the calculator is now reading this as the tangent of 22 degrees, hit enter, and we get 0.404. All right, we'll do one more. We've done a sine, we've done a tangent. The third one we need to know right now is a cosine, and it's going to be the cosine of 20. So if you did the first two, this should pretty be self-explanatory. Here's the cosine function. I want the cosine of 20 degrees. We want 3 decimals, what I said in those directions. So 0.939, the 9 actually would round up to be a 0. Or basically you're taking 39 and it's going to turn it into a 40. So that should be 0.940. And then that's that one. If you have a small calculator, this can also be done. You just need to make sure you're in the right mode. You need to know where those keys are at. All right, so last chance, any calculator questions before I do the last thing here? Okay, then number 23, add this problem. Throw this into your calculator and see what that tells you. All right, what does that give us? He's really out there plugging these in and getting these. So if we throw that into our calculator, what was the tangent of 90 degrees? All right, good. So that should be a problem, right? So if I throw that into my calculator right now, if you see this on your calculator, the calculator never lies to us, right? So if I do the tangent of 90, notice how it says an error. So there are some of these trig functions that we actually can't identify. So for this question, what this is, you would write the tangent of 90 degrees as undefined. Somebody asked last period why that happens. What we know is the tangent is always the opposite side over the adjacent side. If I go to my calculator, let me quit this one. Let me say I do 5 divided by a 0. Think about what that's going to be, and I'll show you what this is in a second. So I'm going to take 5. So if I have $5, I'm going to split it amongst 0 people. Notice what the calculator tells us is an error. We're dividing by a 0. You can't divide by a 0. So what's happening when we do the tangent of 90 degrees, and you'll dive into this in due time in your math lives here over the next year or two, is what we're dividing by when we do that tangent. The adjacent side ultimately becomes a 0. So we're dividing by a 0, and whenever you divide by 0, that's when you're going to write the word undefined. So if you ever come across one of these, if I give you one of these, this would be the answer or how you would answer that question. Right, you just write that word. right? All right, with that, no homework tonight. What I am going to show you real quick, did I get rid of that? Shoot. If we go to our Canvas page, why did I do that? So there's no homework tonight. What tomorrow is going to be, I think I mentioned we may have a quiz tomorrow. We're not going to have a quiz tomorrow.